right, guys, can I just go through this one quickly? This topic, please. Thank you, thank you. All right, so this one, I think the question was maybe a bit unclear. You maybe didn't know exactly where to start from the beginning. So they gave you the series, and they said that it's going to plus 154. Now remember, if they say plus 154 here, this is not the sum. If it said equals 154, that would have been the sum. But because it said plus 154, that is the last term. Now they were asking for the sum of the series, but you can't find the sum of the series if you don't know how many terms there are. Right? Because what are you going to make n? In your SN formula, you need to know what that n value is. So you actually have to recognize that you must first use your term n to find what term that is. Right? By making it equal to your a plus n minus 1b formula. We know what a is, it's 4. The first term. We know what the difference is, it's 5, what we're adding every time. The term is 154, and then we can use that equation to find n. To figure out which term 154 actually is. Alright, so then we get to an n value of 31. That means that this term is term 31. Now I have said this before, I'm going to say it again. If the last term in a number pattern is term 31, because it makes sense that there are then 31 terms in that pattern. Okay, so now if we know that there are 31 terms, now we can find the sum of those 31 terms. Okay, but you did have to find n first. So there we go, n over 2, 31 over 2, 2 times a plus n minus 1, 51 minus 1. That's where that 30 comes from, times d. Type that into the calculator, you get that answer. Okay, any questions? All right, there we have number 10. I think I did help you guys. I just gave you kind of like a breakdown of the steps that you needed to do for this one. It was a very long question. And I think if you get something like this in a text or exam, they'll probably split it up into 2 sub-questions. All right, instead of just one big question. So they'll probably say, term 4 is -1, term 7 is -13. Find the values of A and D. First question. Right, then you know easily what to do. You're going to use your a plus n minus 1b formula. Term 4 is a plus 3b equals -1. Term 7 is a plus 6b equals -13. Then you do that normal simultaneous equation thing that we practiced a few times now. I made a the subject here, subbed it into the a there in the second equation, got my d value of -4, and then a was 11. Right? Then I'll probably say 10.2 or whatever the question is, 0.2. Now find how many terms there are if the sum is -24. Okay, so they probably won't give you one long question like this. But then the sum to n terms is now -24. We don't know how many terms, so we have to say n terms, all right? They told us that the sum of the series is -24. So now we're going to use this formula. Now, guys, quite a few of you started with this line, right? Which is fine because I think it was the first information maybe that was given. Many of you wrote this down. Then you realize, oh, I can't solve for n if I don't have a and b, right? Then you realize, okay, I must now actually use these 2 terms to find the values of a and b. It's fine, all right, if that happens. Then, yeah, you can just look at my working there. Yours can be different. I took that 2 over right from the start. Yeah, I'm dividing by 2, so if I move it over, I have to times by 2. So it was just an n that was left there. A was 11, d was -4. Then I multiplied everything out. I simplified the bracket. I multiplied the n in, and I moved this 48 over. And then, guys, you can obviously, what I did was I divided by -2 to make it simpler, but actually you could go straight from this line to the quadratic formula, right? You don't have to first simplify it if you're going to use the quadratic formula, right? So you could have gone to that line, or from that line, sorry, to the quadratic formula, sub these values in, you would have gotten the same answer. Okay, and then we got to 8 terms. Another question, yes? Yeah, for this one you could have done that because they were quite close together. Yes, it's just that they were very far apart. It would have been. Okay, any other questions, guys? How are we feeling about this work? Okay. All right, we are moving on to a different type of number pattern today, so I hope that you guys are okay with this. Number 30 was actually a bit simpler than the one that we've done before because they just gave us the value of the difference, right? They said that the first difference is 3. That's nice, we didn't still have to calculate that. They said that the sum of the first 16 terms was negative 120, and now we must find 8. Yes. Oh no. But then, oh no, okay. All right, do we see that I made a mistake there? Sorry about that. So this must be negative, right? And then this is going to be negative 60. Then A is minus 30. Thank you for that. Sorry about that, guys. Negative 60, negative 50. Is that my first mistake for the year? Okay. I made it quite long. Okay. So you use your error to A plus A minus 1 with 16 minus 1 B equal to that sum, and then you solve for A. Right. When you are ready, you can write the new heading so long. I must just quickly do absentees. The new heading is geometric progression. And so we've done arithmetic progression. Now it's geometric progression. Okay, that is the heading. Do absentees quickly. Any ideas on what we're going to call this? Arithmetic progression. Those were APs. We're going to call these GPs. Okay, so you can add that on the side. Maybe isn't there. Maybe. Okay. Right, guys, now an arithmetic progression was when we had a constant difference. So we're adding or subtracting the same number every time. For a GP, we are multiplying by the same number every time. All right, so I'm going to make up an example here. No, is anyone else feeling like, no, the time already? The term just started. Okay, so let's look at, trying to find a nice one here. Okay, for example, 2, 6, 18, 54. Right? Do we notice that from 2 to 6? Now, obviously, if you get this first, you'll check whether you have a constant first. Okay? So if you're going from 2 to 6, you're adding 4. Will you get 18 if you add 4 then? No. All right. All right. With these geometric progressions, sometimes you might have a constant second difference. All right. But I wanted to get into the habit of actually first checking or whether you're multiplying by a number. Okay, unless you can see very easily that you're going to have a constant second difference. We will still revise quadratic equations or quadratic factors. We haven't done that yet. Okay. So we see here that from 2 to 6, we are multiplying by 3. And then from 6 to 18, 6 times 3 is also 18, right? And then 18 times 54, I don't know if you know this, but 18 times 3 is 54. Right, so that number that we are now multiplying by is called a ratio, constant ratio. All right, so in this case, we have a constant ratio. We are going to use an R to represent that of 3 for this example. Okay, are we fine with that? That's the only real difference. Okay, now because we don't have a D in this number pattern, we can't use the A plus N minus 1B formula. There is a different formula, which is also on the formula sheet, but obviously it's good for you to know this formula off by heart. So the formula is that Tn is equal to A R to the power of N minus 1. I'm just going to zoom in a bit, it's a bit small there. So that is now the new formula that we are working with. The formula for any term in a GP is A times R to the N minus 1. All right, so just like with the Tn is the general term or the nth term, or if they ask you for the general formula, the general term and formula, which is the nth term. Just like with APs, A is still the first term. All right, we don't change what A means now. A is still term 1. R now obviously is the constant ratio. And N, I'm just going to circle it and do a little arrow. So the N, which is now in our exponent, always going to say N minus 1 in that exponent, is again the number of terms or the term number. Okay, so now what could happen when we are working with the GP is that we might have to solve an exponential equation, right? If they are giving us the value of a specific term and we need to figure out which term that is, we need to find the value of n. N is in the exponent, so we're going to have to solve an exponential equation, right? Which we learned all about last year. So that's something that's new, something that's a bit more difficult than with the A. Okay, for today, this is all we're doing. We're just going to work with this formula. So we are going to do an example now. And they can ask you all the same types of questions that we have done so far. But now just, we're going to have to be able to use a different formula. Okay, are we copying this down, please? And that is the first question. Determine the fifth and eighth terms of the GP 3612. Now, in this question, we have the book, or I told you that it is a GP, but we don't need to do that, right? We can just give you the number pattern and you need to identify. Is it an AP? Is there a constant difference? Or is it a GP? Is there a constant ratio? Okay, so that's now also something new that's coming in. All of the examples that we've done so far have been ones where it was almost given that there is a constant difference. Okay, so we now need to get into the habit of actually checking, unless they told us, like in this question, but if they don't, we need to identify which type of pattern it is. Then we must remember, if it's an AP, we use our A plus A minus 1D formula. If it's a GP, we're going to have to use this formula. All right, so there's going to be a bit more of like a decision-making process now. Okay, but for now, we can see that from 3 to 6, we have 2 multiplied by 2. And from 6 to 12, we also have 2 multiplied by 2. All right, so the constant ratio is 2, and the A value is 3. All right, term 1 is A. I'm just going to rewrite the term M formula because we haven't practiced it yet. So we all know that the more we write it down, the easier we remember it. So that is the formula that we're going to be working with because it is a GP. AR to the N minus 1. Now guys, if you're asking for term 5, do we see like just with the previous formula, the AP formula, again we have an N minus 1 in the formula, right? In the AP formula, it was N minus 1D. Now the exponent is N minus 1. So you don't have to write this as a separate step, but it is going to help us going forward if we get used to this. That term 5 will be AR to the, which is 5 minus 1, which is 4. Now, I wanted to get into that habit. We're going to have to use this just like we did in the previous section. Okay, so term 5 will be AR to the 5 minus 1, which is just 4. Okay, but it's helpful if you are able to do this just in one, just like if you're used to this full process. But term 5 is AR to the 1 less than 5. Okay, and term 8, I'll just do it next to this one, will be AR to the 7, 1 less. All right, 8 minus 1. Now we just need to sub in the actual values of A and R. So A is 3, and then R is 2, and we need to raise 2 to the power of 4. Okay, it's not the whole thing to the power of 4, that's important. It's A on its own multiplied by R to the power of 4. Okay, but if you type it in like this with brackets, then the calculator will just raise the 2 to the power. Okay, you need to use your calculator for this, probably. I don't know, it's 3 times 16. Okay, maybe you know what that is by heart. It is 48. Yeah. Again, you could, but you won't always be able to. So I like to show you guys ways that will always work instead of one. Okay, so here again we have the same A value. Obviously, it's the same pattern. So we have 3 is our A value, and now it is 2 to the power of 7. Okay, now you might not know what that is. It's fine if you don't, and then you have to times that by 3. So that final answer is actually 384. Okay, that's quite simple, I think. All right, let's do one with some fractions. I know we don't like fractions, but we do need to get used to working with them. So given the, now remember guys, progression and sequence, it means the same thing, right? We actually just use progression instead of sequence so that we can call them like an AP and an AX, right? Like an arithmetic progression and an arithmetic series instead of AX for both of them. So that's why, but sequence means the same thing. So we are going to look at this one, given the sequence, negative 1/243. That's the first term. Then we have negative 1/81. And then we have negative 1/27. And then it will carry on. A is asking us to determine the next three terms. So guys, when we get it numbers like this, it's a bit more difficult to actually just see by inspection what the ratio is. Okay. So if you are having trouble with just actually figuring it out by looking at it, there is a way in which you can calculate it. You guys remember that when we did the first difference, we said term 2 minus term 1. You guys remember that? That will always give you the first difference. Right now, in this case, if you take term 2 divided by term 1, that will give you the ratio. Right? But guys, did they tell us that this is a GP in the question? This is given the sequence, so we actually need to check, okay? So you must actually check, are you adding something every time, or are you multiplying by something every time? And then you kind of recognize the pattern in the denominators. Okay, it almost looks like there's some kind of times pattern in the denominators. So let's check, all right? Let's do term 2 divided by term 1. On the calculator, obviously, you can do that. So you'll take negative 1/81. You don't have to write this down. I will just write it down for the purpose of the example. Divided by negative 1/243. Can someone just type that into the calculator? We're getting 3. 2. 3. It should be 3. Just check. All right, 3. 4. Okay, but now we can't just say, okay, there's a ratio of 3 there, so it's a GP. We have to check the other pair as well. Okay, we have to do term 3 divided by term 2 as well to see if that ratio will repeat. Because only if we have a constant ratio will it be a GP. Okay, so we need to do term 3 divided by term 2 as well. That is going to be negative 1/27 divided by negative 1/81. And if you type that in, you will also get an answer of 3. Okay, so we're getting the same ratio twice. So that means that this is a geometric progression or sequence. Okay, so now we can just add maybe there to the top. I don't have space underneath. I'm going to say that that is a times 3 and that is also a times. Okay, so if we now need to get the next 3 terms, we must keep doing that, right? To get to term 4, we have to say term 3 multiplied by 3 again. Okay, so you can use a calculator for that if you want. Negative 127 times 3. Negative 1/9. All right, so I'm just going to say here, therefore, the next term is going to be negative 1/9. Just put here in brackets underneath. This was term 3 times by 3. Okay, if you forget how we got to that value, to get to term 4, you're going to have to do term 3 times by 3. Then we must now take this one, term 4, and multiply that by 3, which is going to give us negative 1/3. Then we must take this term and times by 3 again, which is going to give us negative 1. Okay, so those are the next 3 terms. Right, so this one is term 4 times 3 And this one is term 5 times 3. So whenever they ask you to give the next 3 terms, however many, you just need to keep repeating that pattern. Okay, but in this case, we have to do some work to figure out what the pattern was. Yes. Yes? No, I just wrote that there for in case you can't do it by section. That is the way you can always find the ratio. That method will always work. Okay, that is A. Question B. Oh, and you guys are not going to like this, but we need to do it. Determine an expression for the nth term. In simplest form, which is the part that you're not going to like. Okay, so we all agree that this is easy. So when we need to find the nth term, that's term n, we're going to use the term n formula. Okay, so term n is equal to a r to the n minus 1. A is the first term. What was the first term that we had here? Negative 1 over 243. All right, so that is A. Multiplied by, what is the ratio? 3 to the power of n minus 1. Now guys, the fact that this question is saying in simplest form, and probably also if this was a question that gets go down the mark allocation, right? This wouldn't just be a 1 mark question. This would be maybe a 3-4 mark question, and that should give you, remember, please, we need to also get into the habit of looking at the mark allocation and using that as a guide as to how far we actually need to go. All right, if it was a 1 mark question, perfect, we're done. Okay, but because they've said in simplest form, and it will count 4 marks, we need to start thinking, okay, I'm not going to get 4 marks just for subbing in an A and an R value into a formula that's given on the formula sheet. All right, we need to do some work. We need to actually simplify this. Now, guys, do you remember that factor button thing that I showed you last year on the calculator? I want you to do 2, 4, 3 and see what that gives you if you use the factor button. Just a reminder, if you forgot how to do that, you type the number 243, you press equals, shift, and then you look for the button that says fact above it. And it will tell you that 243 is the same as 3 to the power of 5. Now guys, the reason why this is important in this case is because our ratio is also 3. So we could actually express this as 3 to the power of something, and then we have another 3 to the power of something. What happens when you multiply 2 powers that have the same basis? Add those exponents. Okay, so 1 over 243 is going to be, I'm going to get to that now. Okay, I'm just doing it step by step. I'm just writing 243 as 3 to the power of 5. Okay, and that is times 3 to the n minus 1. Now guys, let's just talk about this minus quickly because it might seem a little bit out of place there. A negative multiplied by a positive expression is just going to be negative, right? So our answer is going to be negative. But now, if we want to multiply these 2 powers together, they have to have the same basis. At the moment, this power does not have a basis, all right, because it's actually a third. So if it's 1 over 3 to the 5, that is the same as 3 to the negative 5. Right? Do we remember that? If we have a base of 3 at the bottom, we want a base of 3 at the top, then we need to take whatever the exponent at the bottom was and change that sign. Okay, we used this quite often last year when we did exponential equations. Okay, so it should be in your books from last year. And that we are multiplying by 3 to the n minus 1. Now we see that we have the same bases. Yes. Yes, you can. Yes. Okay, so now we have the same bases, meaning that when we times them together, our answer is going to have the same base still. You're still going to have a base of 3. But then you're just going to add those exponents together. Okay, now this is another step that you don't have to write down, but just I am going to write it down just because we haven't worked with exponents in a while. I'm just adding those two exponents together. And now obviously those like terms, -5 minus 1, what's that? -6. Okay, so now we have to just write this as -3 to the power of n minus 6. Or you can say -6 plus n, that's also perfectly fine. So that is actually the final answer. That is worth doing. Okay, so guys, please, if they say in simplest form, especially with these types of questions, the GP questions, you often have to try and get the bases the same, the bases of A and R the same, so that you can add those exponents together. And so that's something to look after. Any questions on this one? Okay. Okay, I'm going to give you some to practice on your own. All right, which will have you working with this formula. So, okay, I'll just write it on the side here. Exercise 1.4. Page 11. Okay, 1A and B. And then I'm going to give you 7A. We haven't actually done an example like 7A yet, so I'll just help you on the board quickly. Just write this down, please. Then I just want to give you some guidance for 7A, how you need to start. Okay. Just quickly, if we are looking at, there we go, 7A. They say they determine the first 3 terms of the geometric progression of which, so if they want the first 3 terms, that's going to be A, obviously, is term 1. Then you must multiply it by the constant ratio, right? So we need to find A and R, basically. Now they say of the geometric progression, the GP, of which the 7th term is 192. So you're going to write term 7 equals 192. And the second term is 6. Term 2 is equal to 6. Now, guys, we've done a bunch of these examples with A already, right? Where you would say, okay, term 7 is A plus 6B equals 192, and term 2 is A plus 1B equals 6. Now it's a geometric progression, so we need to use this formula now to express term 7 and term 2 using this formula. Right, so I just want to help you with that one. Term 7 is going to be AR to the 7 minus 1. Right, because if it's term 7, what is my n value? 7, hey? So if I'm subbing that into this formula, AR to the power of 7 minus 1, so 6 equals 192. Right, so it's similar to what we've done before, we're now just using the new formula. Okay, term 2 is going to be AR to the 2 minus 1. So AR to the 1, or you can just write AR. That is going to be equal to 6. Now you have two equations with two variables. What are you going to have to do? Solve simultaneously. It's a bit more difficult now, okay? Because now we have no pluses. You can't just move stuff. Now, if you want to make A the subject in one of these two, you're going to have to move the whole R to the power of everything. Okay, so the actual algebra is going to be different, maybe a little bit more complicated, but this is how you need to start out, guys. Okay, so please take a picture of that or write it down so that you know where to start for 7A. And from there, you can have to solve simultaneously. Get your A value, get your R value, both of them, and then you can find or write down terms 1, 2, and 3, which is what they are. Okay, I'll leave that up there for you, or should I put the first question on? Just quickly take a picture of that. Okay, I'll put 1, A and B, and 2 on the board. All right, 4A and 7A are on the next page, unfortunately, but you can start working on those.